Good afternoon students. Welcome back to online mathematics class. So in the last class we have started with the exercise 9.2 and we have solved up to the third problem. So in today's class let us continue with the fourth one. The question is how many terms of the AP minus 6, minus 11 by 2, minus 5 so on are needed to give the sum minus 25. So here he has given an arithmetic progression and he has given the sum. So how many terms we need in this AP to get the sum as minus 25? So let me write the given AP and the required information. So here minus 6, minus 11 by 2, comma minus 5, so on. So this is the given AP. So here A which is equals to minus 6, A which is equals to minus 6, and then D common difference is going to be second term minus the first term or the third term minus the second term. So now D which is equals to minus 11 by 2, then minus 11 by 2, then minus A1, that is minus into minus it becomes plus, we get 6. Then D which is equals to, take up the LCM now, 2 will be multiplied with 6, you get 12. Minus 11 plus 12 divided by 2. So now 12 minus 11 it is 1. D is going to be 1 by 2. So you have the value of the common difference and the first term. So with these two we can go for SN formula because he has given the sum, it is minus 25. So now Sn which is equals to n by 2 into the bracket 2a plus n minus 1, 2a plus n minus 1 into d. So now Sn which is equals to n by 2. So n is unknown here, write it as it is, n by 2, then into the bracket 2a. What is the value of a here? It is minus 6. So 2 into minus 6 plus n minus 1 into d. What is the common difference? It is 1 by 2. So it is 1 by 2. So now we will simplify this in the next step. Sn which is equals to, okay, we will substitute the value of Sn. What is Sn? It is minus 25. So minus 25 which is equals to n by 2, then into the bracket 2 into minus 6 will be minus 12, and then here multiply 1 by 2 with these two terms, you get n by 2 minus 1 by 2 plus n by 2 minus 1 by 2. So now in the next step you take 2 to the LHS, it will be multiplied with minus 25. So you get minus 50. Minus 50 which is equals to n. So inside the bracket simplify these two terms now. So multiply 2 with this, you get minus 24. Minus 24 minus 1 will be minus 25 divided by 2. So it is minus 25 divided by 2 plus n by 2. So now in the next step minus 50 which is equals to n. Now you have the same denominator. Whenever you have the same denominator, add the numerators if there is plus sign. If there is minus sign, subtract the numerators. So overall it becomes minus 25 plus n divided by 2. So now take 2 to the LHS, it will be multiplied with 50, we get 100. So it becomes minus 100. Minus 100 which is equals to, multiply n with these two terms. You get minus 25n plus n square. So now take this to the RHS, it becomes plus 100. So overall it can be written as n square minus 25n plus 100 which is equals to 0. So this is a quadratic equation. So you need to solve this quadratic equation by factorization method or the formula method. So here I will be going for factorization method. So it is 100. So now in the factorization method, multiply the first and last term, the product is going to be 100 n square. So product is going to be 100 n square. So now how do you consider the factors of 100 n square? So the fact, if we add or subtract the factors, we should get the middle term. So what I do is, I take minus 20n and then minus 5n. Multiply these two, you get the product. Add these two, you get the middle term. So here, n square minus 20n minus 5n plus 100, which is equals to plus 100, which is equals to 0. So now, in the first two terms and in the next two terms, we have to take common. So in the first two terms, we have n common. So we get n minus 20, and in the next two terms, we have minus 5 common. So it is minus 5. We get n minus 20, which is equals to 0. Which is equals to 0. Now, this can be written as n minus 20 into n minus 5. So n minus 20 into n minus 5, which is equals to 0. So overall, n minus 20 equal to 0, or n minus 5, which is equals to 0. So now, here we get n which is equals to 20, n which is equals to 20, or n which is equals to 5. So these are the required number of terms. So for this particular AP, you need 20 terms to get the sum, or you need 5 terms to get the minus 25. So this is all about the fourth problem. Well, the next problem it is, in an AP, if pth term is 1 by q and qth term is 1 by p, prove that the sum of first pq terms is 1 by 2 into pq plus 1, where p not equal to q. So here he says pth term is 1 by q and qth term is 1 by p. Nth term means it is n equal to a plus n minus 1 into d. So here pth term is nothing but AP, which is equals to a plus p minus 1 into d, and qth term is nothing but aq, which is equals to a plus q minus 1 into d. So that we have to write now. So we'll go for the given information. AP, which is equals to a plus p minus 1 into d. So AP, which is equals to a plus p minus 1 into d. What is the pth term? It is 1 by q. It is 1 by q. I call this as equation number 1. And then he has given qth term, that will be aq. So aq, which is equals to a plus q minus 1 into d. A plus q minus 1 into d, which is equals to 1 by p, which is equals to 1 by p. I call this as equation number 2. Now let us solve these two equations. So I'll go for equation 1 minus equation 2. So here solving 1 and 2, solving 1 and 2. So what do we get now? A plus p minus 1 into d, which is equals to 1 by q. Then it is a plus q minus 1 into d, which is equals to 1 by p. So now go for the sign change. So minus, minus, and here it is minus. So these two get cancels, and then in these two terms we have d common. So what I write is p minus 1 and then minus q plus 1, minus q plus 1 into d, which is equals to, here what do we get? 1 by q minus 1 by p, which is equals to 1 by q minus 1 by p. So now here minus 1 plus 1 get cancels, we get p minus q, which is equals to into d, which is equals to, take up the LCM here. So it will be PQ or QP, then P multiplied with 1, we get P minus Q. So now here p minus q and p minus q get cancelled. So you get d which is equals to 1 by pq. D which is equals to 1 divided by pq. So we have got the common difference. Next we have to substitute this in any one of the equation to get the value of a, that is the first term. To get the sum, here actually we have to calculate SPQ. To get SPQ, we need the first term and the common difference. Let us go for substituting now. So now put D which is equals to 1 by PQ in equation number 1. So now here A plus P minus 1 into D. In place of D, I will be writing 1 by PQ. So it is 1 by PQ which is equals to 1 by Q. So now A plus multiply this 1 by PQ inside, we get P divided by PQ, then minus 1 divided by PQ, minus 1 divided by PQ which is equals to 1 by Q. So now P and P get cancels, we get A plus 1 by Q, then minus 1 by PQ which is equals to 1 by Q. So here you take 1 by Q to the RHS, it becomes minus 1 by Q. Both get cancels, we get 0. So here 1 by Q and 1 by Q get cancels. And then I take this minus term to the RHS, it becomes positive. We get A which is equals to 1 by PQ. So we have got the first term as well. Next we will have to go for SPQ. See here, prove that the sum of first PQ terms is 1 by 2 into PQ plus 1. So here now SPQ which is equals to, what is the SN formula? N by 2, 2a plus n minus 1 into D. So here n is nothing but PQ. So we should write PQ by 2. This is n by 2. Then 2a is going to be 1 by PQ. So it is 1 by PQ. Then 2a plus n minus 1 into D. N it is PQ. N minus 1 into D. D is again 1 by PQ. It is 1 by PQ. So now in the next step, SPQ which is equals to PQ divided by 2. Then so here we get 2 divided by PQ, 2 divided by PQ, and then multiply 1 by PQ with these two terms, plus here we get PQ divided by PQ and then minus 1 by PQ. So now in the next step we will simplify this since we don't have much space. So for the time being, note down this and then we'll go for the further steps. Well, let us continue from this step. SPQ which is equals to PQ divided by 2. Then so here, so take up the LCM, it is going to be PQ. So it is PQ, then in the numerator we get 2 plus PQ minus 1, 2 plus PQ minus 1. So here PQ and PQ get cancels. SPQ which is equals to, here we have only 1 by 2, then inside the bracket, so 2 minus 1, it is 1. 1 plus PQ or PQ plus 1, both are same. So it is PQ plus 1. So this is the required answer. So here we have proved that the sum of the first PQ terms, it is 1 by 2 times PQ plus 1. So this is all about the fifth problem. Well, the sixth problem, it is, if the sum of a certain number of terms of the AP 25, 22, 19 is 116, find the last term. That is, we have to find AN or L value. So let us go ahead with this. So we'll write the given EP. It is 25, then 22, and then 19, and then so on. So on. So here A, which is equals to 25, then what about D? D, which is equals to 22 minus 25 or 19 minus 25. It is minus 3. And what is that 116? It is Sn, sum of n terms. Sn, which is equals to 116. So now we will have to get the value of n, and later we have to go for last term. So I will be using Sn formula. Now Sn, which is equals to n by 2 into the bracket 2a plus n minus 1 into d. Then Sn is going to be 116, which is equals to n by 2. Then 2a, it is 25, 2 into 25 plus n minus 1 into d. D, it is minus 3. So it is minus 3. Close the bracket. Then take 2 to the left hand side. It will be multiplied with 116. We get 232. Then which is equals to n into, so it is 50 plus, multiply minus 3 with these two terms. You get minus 3n. Minus 3n, and then minus into minus will be plus 3. Then 232, which is equals to n, write it as it is. Then here we get 50 plus 3 will be 53 minus 3n. Multiply n with these two terms now. 232, which is equals to, so overall you get 53n minus 3n square. Now take these two terms to the left hand side. So overall what do we get now? 3n square, then minus 53n, and then plus 232, which is equals to 0. So we have to solve this by factorization method. So I will take minus 24n and minus 29n. 3n square, then minus 24n minus 29n plus 232, which is equals to 0, or else you can solve this by formula method as well. So now in these two terms we have 3n common. It is n minus 8. Then here we have minus 29 common. It is n minus 8, which is equals to 0. Then so this can be written as n minus 8, and then 3n minus 29. We get 3n minus 29, which is equals to 0. Now we have to equate these two terms with the 0. You get n equal to 8 or n which is equals to 29 divided by 3. But n cannot be 29 by 3. It should be a natural number. So now we are not going to consider this value. So I will be taking n as 8. So let us find the last term, that is an. Therefore an, which is equals to a plus n minus 1 into d. What is n here? N is going to be 8. That means the last term will be a8. It is the 8th term. A value, it is 25. 25 plus 8 minus 1 into d. What is the value of d? It is minus 3. Then so now a8, which is equals to 25. Then 8 minus 1, it is 7. 7 into minus 3, it is minus 21. Then A8 which is equals to 25 minus 21, it is 4. That means the last term for this particular AP is 4. So this is all about the sixth problem. Well, the next question, it is seventh one. Find the sum to n terms of the AP whose kth term is 5k plus 1. So they have given AK equal to 5k plus 1 and we will have to find Sn. We'll write the given information. It is AK which is equals to 5k plus 1. It is 5k plus 1, 5k plus 1, then put k equal to 1, you get A1. So A1 which is equals to 5 into 1 plus 1 which is equals to 6. That is, the first term is going to be 6. Now put k equal to 2 and A2 which is equals to 5 into 2 plus 1. So 5 into 2 it is 10, 10 plus 1 will be 11. It is 11. So now with these two we can find the common difference. So here D which is equals to A2 minus A1. So D which is equals to, it is 11 minus 6, D which is equals to 5. So here the first term A1 equal to A. For this we can also call it as A, and then here we have the common difference. With these two we can find the sum to n terms. Therefore Sn which is equals to n by 2 into the bracket 2a plus n minus 1 into d. So now Sn which is equals to n by 2 into the bracket 2 into A it is 6 plus n minus 1 as it is into D it is 5. So we'll simplify this. Sn which is equals to n by 2, then here we have 12 plus 5n minus 5. So in the next step, Sn which is equals to n by 2, then here 12 minus 5 it is 7, 7 plus 5n or 5n plus 7, both are same. So it has to be 5n plus 7. So with this we have completed the seventh problem. So note down this.